So today's review is on systems of equations and matrices, and we've been talking about our different methods for solving systems. We mentioned substitution, linear combination or elimination, graphing, and then using matrices. So for the first example in your notes, what method did you pick? Which one? You could solve it using any of the ones I've mentioned, right? Any answer would be okay. I'm asking, what did you do? You used elimination or linear combination, that method? How many did that? Okay, it is set up nicely for that because you have all of your equations lined up. Substitution is best if you have a single x somewhere or a single y that's already kind of solved for itself. All right, that makes substitution easy. So if I were looking at this, I would do linear combination, that elimination method. So let's say we're going to eliminate the x's. What would we multiply by? Threes and fours? One of them would need to be negative. Okay. Yeah, it's doing that again. All right, so we would multiply the top equation by what? Four, and the bottom equation by -3? Yes? So I did that. That gives me my first terms being 12 and -12 for x squareds. Okay, so those are going to eliminate. What do I end up with for y's when I add those two equations together? I get a negative y squared equaling, okay, so if negative y squared equals -4, then y squared would equal +4, right? Which means y would equal 2 and -2. Okay. So make sure that you have two answers listed there. You're getting a 2 and a -2, which means we now have to dump those back into our equation to solve for the x's. Okay? So if we dump them in, it doesn't matter which equation we pick, we're going to put that 2 and -2 in for our y. Yes? And the first thing we're going to do with it is square it. So does it matter if I put a +2 or a -2 in? They're going to give me the same answer out, right? So I worked through it, putting them both in at once. All right? So I put a +2 and a -2 in there for y. We squared it, made it a 4. Times by 2 gives me an 8. We've got 3x squared plus 8 equaling 35. Subtracting the 8, dividing out the 3. Once again, we end up with a squared variable. So when we square root, we get two answers out. So that means if I put in a 2 or a -2 for y, I'm getting out a 3 and a -3 for x. So I end up with 4 solutions. You would be expected to list all of those. And now that we've actually done our chapter on conics, look at the equations in this system. 3x squared plus 2y squared equaling 35. What shape is that? Picture solving it and getting a 1 on the end. What's it going to end up being? It's an ellipse. It's not a nice pretty one, right? We're not getting nice integer values for our a's and b's, but it is an ellipse. The second one is also an ellipse. So picture two ellipses intersecting. Can you visualize them intersecting in 4 spots? Okay, so we're getting 4 intersection points. All right, the second question was one of our linear programming problems. Had a lot of steps to it. So first thing you should do is just read through it. Skim through it, kind of get an idea of the information they're giving you. Then you need to go back and look at what questions they've really asked. Okay, so it says a company makes bookshelves and desks. Let X be the number of bookshelves and Y be the number of desks produced daily. The company makes $25 for every bookshelf and $55 for every desk. To maintain their high quality, the company cannot manufacture more than a total of 80 bookshelves and desks combined per day. The company must make between 30 and 80 bookshelves daily and at least 10 but not more than 30 desks. How many bookshelves and how many desks should be manufactured each day to maximize profits? And what is the maximum profit? So the question they're asking me about is profit. Yes? I'm going to create an objective function about profit. Your objective function is what you're trying to maximize or minimize. So rereading the question, where do you see information about profit? Yep, I tried to color code things here. Maximum profit says the company makes $25 on every bookshelf and $55 on every desk. Okay? So how can I write an equation for that? Profit equals 25x plus 55y. Okay. There's my objective function. I'm going to set that equation aside for now because I don't need it until the very end. Okay. Second thing I look for are the constraints. What limitations am I given? So go back and reread it. In green, it says the company cannot manufacture more than a total of 80 bookshelves and desks combined per day. How can you write an inequality statement about that? X plus Y is less than or equal to 80. Okay, that's one of your constraints. The second statement in red says the company must make between 30 and 80 bookshelves each day. They're giving me a low end and a high end, right? Somewhere between 30 and 80. That's my next constraint. Bookshelves, which is X, has to be somewhere between 30 and 80. Now you can write that as two separate inequalities. You could say X has to be greater than or equal to 30 and X has to be less than or equal to 80. That's just as easy to write a compound one. Okay. In black, it says we have at least 10, but not more than 30 desks. So same idea. Desks is Y. So Y has to be between 10 and 30. Okay. Now, when I go and take these constraints, there's often two that are implied but not really stated in the word problem. All right, when we went through this chapter, we had a lot of cases where we said X and Y both have to be non-negative. I can't make negative bookshelves and negative desks. Okay, but for this particular problem, they gave me a different lower cutoff. They told me that I can't go below 30 for X and below 10 for Y. So I don't really have to say X has to be greater than or equal to 0 because I've already given it a separate cutoff. Does that make sense? But a lot of times you do have that limit of being in quadrant 1 where everything's positive. All right, so for our graph, we need to graph all three of these constraints. What's the first one going to look like? The X plus Y is less than or equal to 80. I'm seeing you hold up lines. Yes, it's going to be linear. Okay, if you put a 0 in for Y, you get 80 for X. If you put a 0 in for X, you get 80 for Y. So you have X and Y intercepts at 80. So you have a diagonal line. Yes? Okay. Would we shade above or below that line? Below, because the origin works in that statement. Okay. So we've got this diagonal line, we're shading below. All right. The second one, the red one, it says X has to be between 30 and 80. Well, what would X equaling 30 look like on my graph? Just X equals 30. X equals 30. Well, you're showing me both vertical and horizontal. Pick one. You got to pick one. Vertical. X's have to be 30. Yes? So picture all the points on that vertical line have an X value of 30, right? Y can be anything, but X has to be 30. So if they are telling me that X has to be between 30 and 80, I'm really looking at two vertical lines and shading in between them. Does that make sense? Okay. And then for our yellow one, Y has to be between 10 and 30. What would that look like? So now I've got two horizontal lines, right, at 10 and 30, and I need to be in between those. Okay, so looking at our overall picture here. The yellow was the horizontal stuff that we talked about. We need to be between 10 and 30. So I'm shading in between the yellow lines. Shading in between the red lines. I need to be between 30 and 80 for x. So I really have this box right here, right? And then I cut it off with my diagonal x plus y has to be less than or equal to 80. Okay? So you should end up with the blue trapezoid-shaped region. We good with that? Okay. What's the next step? Find the vertices. Now, if you graph carefully, and we got a lot of vertical and horizontal lines, which made it nice and easy to find our corners. All right, we should have the points 30, 10, 30, 30, 50, 30, and 70, 10. We okay with that? So what do we do with those vertices now? Plug them where? Back into your objective function, okay? So, did that. It makes too much sense. I'm sorry. If I try the point 30, 10, dumping it in my objective function, I get a profit of 1,300. If I use the point 30, 30, I get a profit of 2,400. 70, 10, I get 2,300. And 50, 30 gives me 2,900. So what am I going to pick? The 50, 30, right? That gives me the biggest profit. So my answer would be, my maximum profit would be $2,900 if I make what? Because they asked me two questions. What's the maximum profit? And also, how many of each thing do I need to make? So I need to make 50 bookshelves and 30 desks. Make sense? Okay. The last couple questions deal with a quick review of matrices. I did cross off the use Gaussian elimination with back substitution. If you were going to do this by hand, that's what I would have you do. All right, but we are going to use calculators for this part. So, what options do we have using a calculator? We could use RREF. Okay, if we were going to use RREF, how do we start our matrix? What's it going to look like? My question, I guess, is, am I going to make a matrix for all the variable pieces and then a separate matrix for my constants, or do I put it all into one? If I'm going to use RREF, I put it all in one, right? It's called an augmented matrix. Yes? What would the size of that matrix or the order of it be? It's what? I'm hearing 3 by 4 or 4 by 3. Which is it? 3 by 4. It's 3 rows, 4 columns. Yes? So I should be entering a matrix that looks something like that. And then you said we're going to use RREF. Where do we go to get that? Go into your matrix screen and then over to math. And then you have to scroll down a little ways, right? If you pick REF instead of RREF, what you're going to end up with is a matrix that has ones for diagonal. Everything on the bottom section here would be zeros, but you'd still have numbers in the top. And if you do that, then you have to do the back substituting. Okay, you figure out what z is, you plug it back into the middle equation, get y, plug those back into the top equation to get x. If you go ahead and use RREF, you're getting to reduced row echelon, which means all you should have is a diagonal of ones. Okay, so we should get that type of matrix. Yes? So your last column is giving you your answers. But we don't leave it like that. What do? We take those answers and we write it as we're writing it as a point, but it's a three-dimensional point, right? It's an ordered triple. So x is 6, y is 3, z is 5. Okay, we are trying to find the point that fits in all three of those equations. Questions on that? Okay. All right, last one deals with matrix multiplication. The first thing you should do is check the sizes, the order of your matrices. You don't want to go through a lot of work to multiply something and then realize halfway through that, oh, wait a minute, this isn't working out. Okay, your first matrix is a 2 by 3. Your second matrix is a 3 by 3. Or sorry, a 3 by 2. So how do we decide if we can multiply them? Middle numbers. If they match, we can do this, right? The outer numbers tell me what? How big the answer is going to be. So I know that this is going to be a 2 by 2. Yes? All right. To get those numbers in our 2 by 2 matrix, we're looking for 4 answers, right? 4 numbers. I'm going to take row 1 times column 1. I'm going to take row 1 times column 2. I'm going to take row 2 times column 1 and row 2 times column 2. Yes? Now, you will have your calculator out for your test. You will be able to check that on a calculator, but I do want to review how you do it by hand. Okay? So, row 1, column 1. We're going to take 4 times negative 7. We're going to take negative 1 times 1, and we're going to take negative 3 times 3. Okay? So first times first, second times second, third times third, and then we add them all up. Yes? So we should be getting a total of negative 38 for that first entry. Okay? Row 1, column 2. So 4 times 4, negative 1 times 5, and negative 3 times negative 2. So we end up with 16 plus negative 5 plus 6. Yes? 16 plus negative 5 plus 6 gives us 17. Okay? Then I do the same thing, but I use row 2. So bottom row times first column. We've got negative 14, 0, and 6, which gives us negative 14 plus 0 plus 6, 8. And then last one, we get 8 plus 0 plus negative 4. Okay. Questions on that at all? All right. I have a worksheet for you that has these questions on it, since most of you have turned your books in already.